itself where we have got m equal to ms a by 2, and actually this particular value a by 2, this theoretical calculation is doesn't agree with that of the experimental result. So I think I have discussed with you at this point that we will go for some other direction. Iteration means some other different trial. So in iteration 2, it was up to the third order e to the power 8 was expanded up to 3 times. Okay, one more thing, that in particular attendance sheet itself, write your proper name and class roll number. Okay, so it is being recorded and it will be there uploaded in your attendance sheet. Keep this thing in mind. So for iteration 3 itself, e to the power 8, we have increased it up to 4 times. Now what is the value function LA? LA is equal to 4 hyperbolic A minus 1 by A. So it was of the form e to the power A plus e to the power minus A by e to the power A minus e to the power minus A minus 1 by A. I think it's right. So this particular dynamic function A, and we were discussing, if you remember, A was of the form mu m8 divided by 80. So we have already discussed one of the extreme conditions where H, the applied external magnetic field H is very high and temperature of the system is low. So here itself for case we are in the process that if this temperature T is high, H is low, then for this particular point A is tending to 0. So we are in the middle of this particular condition, the discussion of this point. In the limit of A tending to be 0, so LA is equal to e to the power A, that is 1 plus A plus A square by 2 plus A cube divided by 6 3 factorial is 6 minus plus e to the power minus A 1 minus A plus A square by 2 plus, and then it will be minus 8 divided by 6. All this divided by the same thing. 1 plus A plus A square by 2 plus A2 by 6 minus 1 minus A plus A square by 2 minus A cube by 6, and all this minus 1 by 3. So we will remember this particular discussion. Let us first check what are the terms that we are using. So e to the power minus A, 1 minus A plus A square by 2, because it's a square, minus A whole square, then minus A cube by 2 factorial, and 2 factorial is 6. So what is being transformed here is plus A minus A, then A cube by 6 minus A cube by 6. This is also constant. Then 1 minus 1 cancel, A square by 2 and minus A square by 3. This is also constant. What all we are getting here? This is equal to 2 plus 2 A square divided by 2 or divided by 2A plus 2A cube by 6 minus 1 by A. So let us first take 2 factors from the numerator, 2 from the denominator. you get 1 plus a square y2 divided by a into 1 plus a square y6 minus 1 by 2. So, in the limit of a tending to 0, what all can be done? See what you can do is, directly you can do is limit of a tending to 0. So, limit of a tending to 0, this factor a becomes 0, a becomes 0, it is 1 by a minus 1 by a, and again the same thing. Like because that is equal to 0. So what we are going to do here is that let us first increase the factors. That is the number of terms. Then the difference becomes justified
Excuse me,
for
sir.
to be equal to 0. So 1 by a 1 plus a square by 1 plus a square by 6 to the power minus 1 minus 1 by 1 by a 1 plus a square by 2 1 plus x to the power n that is equal to 1 plus n into x. So we can write this 1 minus a square by 6 minus 1 by 8. Then this is equal to 1 by 8, 1 into 1, 1 minus a square by 6 plus a square by minus 8 to the power 4 by minus 1 by 2. The limit of the table is 0. First we will check for which ones can be directly transformed. Can you see 1 by a from the first term? After that, first let us simplify. Minus a square by 6 plus a square by 2. Same form, same terms, a square by 2 minus a square by 6. This is equal to 6, 2 into 3, 3 a square minus a square, so 2 a square by 6, that is equal to a square divided by 3. So we can write this down as 1 plus a square divided by 3 minus a to the power 4 y 12 minus 1 by 3. What all we can get is 1 by a plus a by 3 minus a cube divided by 12 minus 1 by 3. 1 by a, 1 by a cancel. Use the limiting condition of a tending to 0. You understand that a is tending to be 0. So suppose if a is equal to 0.01, that means 1 is to 10 to the power 2. In that case, a cube term, this a cube becomes equal to 1 into 10 to the power minus 2 whole cube, that is equal to 10 to the power minus 6. So compared to 10 to the power minus 2, 10 to the power minus 6 is very small. That means using the limiting condition, we can directly write that this particular term a cube by 12 can be eliminated, and this non-given function held a has a value a by 3. Interestingly, this iteration P, the value of LA, this is in correspondence, in consonance. This tallies with the experiment result for the Langevin function, the Langevin factor from different describe the results of different types of parametric. So this was the universal factor that LA can be taken equal to A by B. Now let me clarify some of the points. As I have discussed with you previously, that this Langevin function, this particular discussion, this theory was given proposed in the year 1904, and now we are in 2025. So by this time, many of the computational softwares have been developed by theoretical and computational chemists and physicists. So you will see that in many of the complex structures that suppose we take a very different type of alloy, a tri-dope alloy, a four-dope alloy, any complex type of compound, there may be a slight change in the value of this thing. So we have got some of the research papers that this A value instead of 3 is turning out to be in the values of 2.92 to 2.99, near to the same. Provided you understand that this may be due to the chemical interaction of a particular lattice ion with that of the neighboring ions. And in the theory being proposed by Langevin, this particular factor was totally eliminated. This factor was totally neglected. We considered each of the particular atomic electron, the magnetic moments, as single entity, such that the trajectory of motion of an electron is independent of the motion of the nearest other charged ions. But that is not the factor, but that is not the reality. So there is some changes. This is the reason that now after doing the development of density function of the ab initio methods, I am not discussing in detail about all this because right now you are at a very preliminary stage of quantum mechanics. So once you understand, unless you understand that how to write the wave function for two particle system or n particle system, any two magnets, it is very difficult to go and discuss in detail about this factor. But right now, this must be clear in your mind that this LA equal to A by 3 is near to the actual answer. You cannot actually discard this that okay, yes, that 1904 theory is nothing of much value at the present time. That is not the case. You can see it's the value LA denominator is a factor of 3, but here itself the value changes from 2.92 to 2.99. There is not much change in this particular factor. So, going in continuation with the discussion, what we have to do according to your syllabus, we will confine our discussion to LA equal to A by 2. Now, LA equal to A by 3, and if you remember just run a number of pages, you will see that we have got the expression of magnetization plane is equal to ns saturation magnetization multiplied by 8 times. I think we have done this. That we multiply it with a small n, that is the number of atoms per unit volume. That thing also we have done. Where ns is saturation magnetization. ns, just recall, this was said to be the maximum magnetization. Magnetization at the saturation state. Magnetization at the saturation state. So n equal to ns, and this saturation magnetization is equal to n multiplied by n, where n was the magnetic moment of each atom and n was the number of atoms per unit volume present in the parametric system. और magnetization का definition ही होता है induced magnetic moment per unit volume. इसीलिए जो small n है अगर आप पहले नहीं लिखे हैं, you can write it again. M is the magnetic moment of each atom. N is the magnetic moment of each atom. And N is the number of atoms, number of atoms per unit one. Present in the diamagnetic. So M is equal to Ms into LA. Now we can write LA also equal to M divided by Ms. So remember one thing, this particular LA M by Ms, what is this equal to LA? What we have observed A by B. If you remember in case 1, this LA was equal to 1. That was purely a theoretical assumption. That was purely on theoretical ground. There was no experimental basis. When I was discussing with you in the class about distance, you remember that torque itself, or tau, which is responsible for one directional orientation of the magnetic moment, this torque tau, which is equal to mu s cross b. So if we write it in magnitudinal form, it's the magnitude of spin magnetic moment multiplied by magnitude of applied external magnetic field and cos of the angle theta, where theta is the angular projection between the direction of spin magnetic moment and applied field. Sorry, it is not cos theta, it's a cross product. So actually it is equal to sine theta. So there may be a possibility that some of the magnetic moments may be directly in the direction of the magnetic field B. That means there itself the theta will be equal to 0. Also, some of the spin magnetic moments may be anti-parallel to the direction of the magnetic field. So there the theta becomes equal to 180 degree. In both these circumstances, the torque tau becomes equal to 0. And if the torque tau becomes equal to 0, that means some of the magnetic moments will be independent of the applied external magnetic field B. So they will not get aligned in a specific direction. That means we can never attain the situation of 100% magnetization. So the concept, the theoretical calculation that M equal to Ms, but because in that case LA was equal to 1, where H was high and T is low. So that means LA can never be equal to 1 in practice, in experimental situation. It's only on the calculation basis where we got M equal to Ms. Actually, experimentally, this particular results resembles with that of the experiment. A LA equal to divide 3. So let us just make our make a graphical representation of the mathematical calculation. What we are right now going through. LA equal to M by Ms equal to A by B. This the above value of LA is in agreement with the experimental calculations of magnetization for a paramagnetic expression. So let us talk about on y-axis we have an A and on x-axis there is A. So how can A varies with that of B? And what is this NA? Let me again write. This is equal to M by NS. You remember NA we have previously obtained the value in trigonometric form as cot hyperbolic A minus 1 by 3. So the curve nature of LA, it increases from 0, it is 0 at the 0 value, and it touches the saturation magnetization asymptotically at infinity. The LA curve, this is the value MS, that is M becomes equal to MS. This is the saturation magnetization state. M equal to MS. The curve LA never touches the saturation state. It is not possible. Now LA versus A, if the curve is of Y versus X, from this particular equation itself, LA by A is equal to 1 by 3. So y versus x, dy by dx, y is A, x is A. So y versus x is equal to 1 by 3. When you make a particular tangent, so to a curve, you get the value of tan theta. That is the variation of y with respect to variation of x. So it is dy divided by dx. So LA versus A, it's a straight line curve. It only touches LA at the origin, and then this has a value theta. The theta is equal to tan inverse 1 by 3. So this is the condition of parametric expression. LA by A equal to 1 by 3. Y versus X, this is nothing. That is equal to tan theta. This implies theta is equal to tan inverse 1 by 3. Y is equal to mx, LA equal to A by 3, y is equal to x divided by 3. So it's a straight line curve for passing through the origin. There is no seam, there is no y-intercept. So it's something which is passing through the origin. So this is the condition of paramagnetic situation. M is equal to ms into A divided by 3, M equal to ML, A equal to mu MH, 3 was already there, and in A you have the denominator KT, so M, the magnetization of a paramagnetic expression, mu N square into H divided by 3 KT. This magnitude value of magnetization M M divided by magnetic field intensity 8. This is mu n m square divided by V K. This is nothing but is equal to magnetic susceptibility by M at intermediate level class 12. Whatever method you have followed, you have been made to rote memorize. आप याद किए थे I M the magnetic susceptibility or the paramagnetic specimen is C divided by D. Some constant factor C, which is said to be the unique value, the unique constant, and it is inversely proportional to temperature T. The same is the situation here. Mu is a constant, it is a permeability, magnetic permeability of the medium, so it depends upon the nature of the material. Again, n is the number of atoms per unit volume. That is not going to change during the experiment. M the magnetic moment of each atom. That is also not going to change during the experiment. So K is something which is the Boltzmann constant, a universal constant. 3 is a number. So everything now depends upon the T of the other. जब लैंग्वेज स्केल या पैरामीटर्स को डिस्कस करें हम आपके सामने दो कंडीशंस दो फैक्टर्स को रखते हैं. Two of the external factors are there. One is the applied external magnetic field and the next is the temperature of the system. इसीलिए लैंग्वेज साहब के पूरे डिस्कशन में we have done classical Boltzmann, Maxwell Boltzmann statistics and we have assumed the condition that the system is in thermal equilibrium. क्योंकि this chi m suppose I write it as C divided by D. So you understand that if this particular T, the temperature of the system increase and if it increase such that it is able to overcome the one directional orientation of the magnetic moments, then there will be thermal agitation. The magnetic dipoles will get disoriented and the paramagnetic system will again turn out to be a non-magnetic field. So this is the condition that chi m, the magnetic susceptibility, is completely dependent upon the factor of the Curie constant divided by temperature T. T is the most important external factor. So if you write some answers, that the magnetic susceptibility of a paramagnetic specimen is dependent upon the external factor of temperature T, is dependent upon the external factor of temperature T. Hence, if the temperature of the system increases to an extent, if the temperature of the system increases to an extent such that it overcomes, that value, the magnitude of torque, which aligns the spin magnetic moments in a specific direction, which aligns the spin magnetic moments in a specific direction. There will be thermal agitation in the magnetic dipoles. There will be thermal agitation in the magnetic dipoles. As such, the magnetic dipoles will get disoriented, and the system will undergo phase transition, from paramagnetism and unmagnetized material. So this was all about the Leibniz theory of paramagnetism. Now, during the discussion itself, I have discussed in detail about ferromagnetic discussion. So in continuation to this, we will be discussing about West theory of ferromagnetism. West theory of ferromagnetism. West was another scientist, so he was also working on magnetic materials. Now, his theory is an expansion. This particular theory of ferromagnetism is actually an extension of Langevins theory of paramagnetism. But I think we have discussed in detail about ferromagnetic substances are those which are strong magnetic moments. I have discussed it in class about magnetic domains, why domains are formed, that free energy is present. Everything I have discussed with you in the class. So you see, Langevins theory of paramagnetism, the magnetization M is of the form ms into A by 3. This was the expression given by Langevin. Now, when A is equal to mu n h divided by kT, mu n h divided by kT. Now, when we try to differentiate between para and zero, apart from the external characteristics, what makes the difference between the two is that the ferromagnetic substances have the high value, high density distribution of unpaired electrons. So that's why it has a very strong tendency to attract the magnetic field lines. That means those particular in a small region, those particular magnetic moments which are getting aligned in some specific direction. So this gives rise to a strong coupling between the magnetic moments. So there is a very strong coupling between the magnetic moments. This is the difference between para and ferro. Whereas in para, this theory becomes successful almost to an extent of 95 to 97%. Means in 1904, if 3 changes to 2.97, then it is nothing. Because I took a very strong assumption that we are not considering any correlation. Correlation means any interdependence of the motion of one electron with respect to the other motion of another electron. But that thing cannot be reflected in the case of ferromagnetism. Entire of the ferromagnetism is based on the fact that in a particular domain, magnetic dipoles are aligned in some different, in a particular specific direction. So these particular magnetic moments which are aligned in some specific directions, this means this gives rise to this is possible because of the strong coupling of spin magnetic moments. Spin magnetic moment. I think I discussed in detail to everything that as because the number density is very high, so they are being bound in some particular definite direction. there is not much space in the each particular motion of an electron with respect to the nucleus is the motion of the electron is analogous to that of the bar. So you are the north pole, you are the south pole. Now this direction anti-clockwise. When it is anti-clockwise, that means the spin direction is outside the plane of the black hole. So again the same situation. Suppose there is another particular magnetic dipole, again in the same orientation, same particular direction. So north pole and south pole. Magnetic field lines emerge from the north pole and they converge on the south pole. My understanding is that as because they are running in the same direction, the magnetic field lines are in the same direction. So here itself the point is these two are magnets, these magnetic particular lines will change their direction so that the system becomes stable. There will be a modification in the trajectory of the magnetic dipole. They will try to move apart. So the same is the situation here. These particular magnetic dipoles, as these magnetic moments are in the same direction, so there is a strong spin coupling which is said to be the correlation factor. Correlation factor means that the motion or the change or the orientation in the spin moment of one particular atom is going to affect the spin moments of other atoms. So I gave this example before also in the class, but in a particular test, at the most suppose like set. But suppose you are being constrained, you are being forced to set that 10 to 12 students will sit in one particular test. So the motion or any particular change in the posture of one student is going to affect the sitting arrangement, the sitting position of the other students. So the same is the situation here. This gives rise to a strong coupling of the magnetic movement. So there is a strong correlation factor. So what West did is he modified what the assumption was taken by Randall. He just overcame that factor. And he said that in a ferromagnetic specimen that we will be taking one particular internal field. So there is a particular internal field which is responsible for the magnetization, which is responsible for the strong coupling of the magnetic. So this particular internal field Bi is proportional to the magnetization of the material, it is dependent upon the nature of the material, and in ferromagnetic material, suppose there is solid and nickel. So whatever is the value of magnetization in iron, that may not be same for nickel. So it depends that the Bi is proportional to 10 and Bi is proportional also to a factor known as West factor. Small b, this is said to be West factor. This West factor is responsible for the strong coupling of the magnetic field. Now, how this particular internal field is being developed, I think today the time is almost over. Tomorrow we will be discussing about this. So, if there is a particular question from your side, you can ask. Anyone? If you have anything to say here itself, you can write there in the chat box, or if you want to say something. I request everyone to write properly their name and class phone number in the attendance sheet. So it is mandatory because that will be recorded in the attendance register itself. Keep this thing in mind. So if there is no issues, no problem today, then we end up today's class. Tomorrow again we will meet at 10 o'clock and we will continue with this particular discussion. Thank you.
विष्णु अटेंडेंस कहाँ देना है?
अरे भाई विष्णु बता भाई, अटेंडेंस कैसे लेना है? निकल गया का?